Greetings, Earthlings. Have you ever seen a flower in the most surprising location and been absolutely overwhelmed by its natural beauty? Well, I happened to see one, and it was on Mars. Welcome to the Mars Desert Research Station. It is here where our crew embarked on an analog astronaut mission. Analog meaning it is similar to what we would experience on the real red planet. Now, this was more than a mock exercise. This was a chapter in humanity's epic journey to Mars. For 2 weeks, our crew lived together and worked on research projects spanning the topics of agriculture, energy, health and human performance in space, communications, robotics, and art. As you can see, it was very interdisciplinary, and this collaboration is what we need when we're going to live and thrive on Mars. It's this collective spirit that fuels exploration and uncovering mysteries of other planets. So I invite everyone here to try this spirit of exploration right here, right now, and we are going on a virtual field trip. Our destination, the South Pole of Mars. Now, behind me is a fascinating geomorphic phenomenon that takes place on the South Pole of Mars, and these are CO2 gas jets. Now, scientists have studied its formation, they've witnessed the aftermath, they've even replicated it in the lab, but we've never seen it happening in real time yet. So we have to learn more about this. As the jets blast sediment into the air, 100 meters into the sky, what falls onto the ice are fans and blotches of the sediment. This can give us more information about the winds on the surface of Mars. And as well, it gives us evidence that this does indeed exist. As winter turns to spring, what's left are these stunning areniform patterns, spider-like formations that are carved into the sediment where the gas has eroded channels. It's so beautiful. Interestingly enough, the South Pole of Mars is the only place where this occurs. So this could give us a glimpse into what the planet was like in its history. The power of citizen scientists, that is, everyday people, anyone, anywhere, was at the background of this discovery. They contributed their analysis to all of this data. It truly shows the collaborative nature of exploration. So, what if we could visit this location on Mars? That would be pretty cool. Well, yes, temperature-wise. But think of the discoveries that could happen. We would learn so much more about this phenomenon and how it influences Mars's climate and landscape. It would provide a crucial ground truth to complement the existing satellite imagery. So, introducing Atmosfinder. This is an experimental prototype robot. And its science objective is to indeed do just that, investigate the CO2 gas jets by collecting environmental sensor data as well as visual data. And I'd like to point out the high technology that's being used here, repurposed snow toboggans as sails so that it's passively propelled by the wind. So where exactly are we going to bring this robot? We need to hone in on the region of interest. To the east, there's a lovely layered deposit, sort of like a cliff. And in front of us is smooth sailing, perfect terrain for a robot. It just so happens that the name of this location is Manhattan. All right, we're going to Manhattan on Mars. Let's go. But first, we'll need to suit up into spacesuits. So whenever an astronaut goes outside into space, it's known as an extravehicular activity, or EVA for short. Here you can see it's a multi-person effort to get this crewmate prepared to go outside. So she's connecting the airflow for the helmet, and then the other crewmate is going to switch on the fans, so that way inside the helmet you're always at a temperature control. Then we enter into the depressurization area to get prepared to step foot onto Mars. And here we are, on Mars. We have set foot on Mars. Now we can test our research experiments outside and see what they're like in this environment. AtmosFinder completed 7 EVAs, and each one we added onto the robot after every single test. Now, admittedly, there were a few pieces that we anticipated would break, and they did break, but it led to one of the key design elements being duct tape. So much duct tape. And perhaps using copious amounts of duct tape to solve a problem is something a few people can relate to. During the span of the mission, there was a pivotal moment of teamwork that really helped this project. When attaching the sails onto the robot, a crewmate noticed that these could use some extra reinforcement. And so she also happened to notice that the shelves in the garden area have posts that are about the same diameter as the ones on our robot. So she quickly dismantles it, brings it over, we test fit it in, and it worked. It saved our project, and we could continue on reaching further testing. It was a great moment of collaboration. And then there it lay in the sand, a frumpled heap of tubes, 3D printed pieces, electronics, and you guessed it, duct tape. Despite how it looks, this was not a failure. We gained clarity from each iteration. It was persistence on how to improve it even better. As well, the various perspectives that were gained and the learning along the way. By the end of the mission, AtmosFinder achieved a 100-meter roll, completely unassisted, as propelled by the wind. Woo! It logged environmental sensor data, even when it was rolling down a hill. Yeah. It did autonomous control of its sail motors based off of a wind sensor, and we reached our stretch goal of human-robot interaction in fully suited spacesuits, controlling the robot's vision system. And of course, we implemented party mode on the robot because every robot needs a party mode. Yeah, just like that. Human-robot interaction. There we go. Okay. Okay. All right. So why should we care about CO2 gas jets on Mars? What impact does it have? At the core, it all comes down to sand. You see, every year, the Saharan desert releases sand that gets transported all the way across the Atlantic Ocean to the Amazon rainforest. These tiny pieces contain essential nutrients for plant proteins and growth, and that enables the Amazon to flourish. As well, on Mars, we have seen from orbital studies that winds transport sediment across vast stretches of the planet. So in both of these cases, we can see the role that sand plays. It weaves ecosystems together, revealing the natural force that might be quiet is still very immense. There's another aspect to this as well, and that is that sand can be a symbol of persistence. You see, each grain can represent a piece of learning from an experiment. On its own, it's small, it's unassuming, but well, when we gather these, that's when it creates vast landscapes that endure and transform over time. Persistence can shape the understanding that we have of the universe. Mars might seem far away, but the starting point is closer than you think. AtmosFinder was built on countless hours of practice, not on some far-off planet, but right here. You see, Bowie the robot, which was a predecessor of AtmosFinder, encountered lots of testing from the Westboro Beach community right here. They would all come out and experience the robot, engaging with it, interacting with it, learning about its mission. They were actively participating in this living experiment. It was collaboration and it was persistence in action. This was just truly exciting, the enthusiasm and encouragement from this community. It really laid the groundwork to something so much more. From the sands of an Ottawa beach to the simulated sands of Mars. When we arrive on Mars, the beauty of nature will mean so much more. Think of the distance it will have traveled. It represents way more than a combination of scientific parameters to optimize growth. Just like on Earth, we will have to remember that the plants have a life, a spirit, and a name. By implementing these core tenets of persistence and collaboration, it enables us to embark on these grand challenges, whether it's going to Mars or those in our everyday life. So, the next time you come across a wonderful opportunity or a challenge, I invite you to try this. Try implementing persistence and collaboration. Just don't forget to bring the duct tape. Thank you.